Welcome to Code Instinct. In today's project, we're crafting a fully responsive weather card application using HTML, CSS, and JavaScript. This project will allow you to display real-time weather updates for multiple cities with smooth responsiveness and interactive hover effects. Whether you're looking to improve your JavaScript skills or build a modern, dynamic interface, this is the perfect hands-on tutorial for you. A huge thank you to all our amazing patrons on Patreon for supporting Code Instinct and making these tutorials possible. If you're interested in accessing the complete source code for this project and many others, you can join us on Patreon starting at just $3 per month. Your support keeps the content flowing and helps the community grow. Begin by preparing the project files. We'll start with a blank HTML file for the structure, a blank CSS file for styling, a folder named Images containing weather-related icons, and a JavaScript file to handle the dynamic functionality. Once the setup is ready, let's dive into the coding. The structure inside the body tag begins with a heading, H1, that displays the title of our project, Responsive Weather Card. This heading is styled to be visually prominent and centered, setting the tone for the application. Next, we create a container div with the class weather container, which acts as a grid layout to organize our weather cards. Inside this container, each individual weather card is represented by a div with the class weather card. A div with the class city name is used to display the name of the city. It's filled with static text, such as London, New York, or Tokyo, depending on the card. An image tag with the class weather icon is included to display an icon representing the current weather conditions. Initially, the src attribute is left empty to be dynamically updated via JavaScript, and the alt attribute is set to weather icon to maintain accessibility. Another div with the class temperature is used to display the current temperature. It's initially filled with placeholder text, showing degrees Celsius. Finally, a div with the class weather status displays a brief description of the current weather conditions. Like the temperature, it starts with a placeholder text loading, which will later be updated dynamically. This layout is simple yet effective, ensuring that each weather card contains all the necessary details while remaining structured and easy to read. It is also designed to accommodate dynamic updates, making it a functional base for the interactive weather application. Starting with the body element, it is styled to create a visually pleasing and centered layout. The property font family, Arial sans serif, ensures text is displayed in the Arial font with a fallback to any sans serif font. The background color is set to a soft blue. To eliminate any default spacing, margin 0 is applied, while padding 10 pixel adds a small amount of internal space around the content. The display flex property turns the body into a flex container with flex direction column. Arranging its child elements vertically, the properties justify content center and align item center will center the content both vertically and horizontally. To ensure the layout spans the full height of the viewport, min height 100 VH is used. The box sizing border box rule includes padding and borders in the element's total size calculation. Lastly, the text color is set to dark gray for better readability. The H1 element, which serves as the main heading, is styled for emphasis and responsiveness. The font size is determined by font size for VW, making it scale based on the viewport width. To create separation from subsequent elements, margin bottom 70 pixel is added. The text color is set to a muted teal color, and the text align center property 2 centers the heading. The weather container class is responsible for organizing the weather cards. It employs display grid to create a flexible grid layout, with gap 20 pixel defining the spacing between grid items. The grid template columns property will ensure the cards adjust dynamically, with each column having a minimum width of 150 pixel and sharing available space equally. The container's width is set to 100%, but its maximum width is capped at max width 1000 pixel to maintain a clean layout. Each individual weather card is styled using the weather card class. The background property gives it a soft white background, while border radius 10 pixel rounds its corners for a modern look. A subtle shadow effect is added with box shadow property, creating a floating appearance. The text align center property centers all text inside the card, and padding 20 pixel adds internal spacing. To enhance the card's visual hierarchy, transition transform 0.3 seconds creates a smooth animation effect. The aspect ratio 3:4 property ensures a consistent aspect ratio, while display flex enables flexible positioning of child elements. The properties flex direction column, justify content center, and align items center align the content centrally. Lastly, border 1 pixel solid adds a light border, and cursor pointer changes the mouse pointer to indicate interactivity. On hover, the weather card hover rule applies transform translate Y -10 pixel, creating a lifted effect. Within each card, the city name class styles the city name. The font size to value property ensures the text scales with the viewport, while font weight bold to adds emphasis. Margin bottom 10 pixel separates the city name from other elements, and color applied is a muted blue tone. The temperature class defines the temperature display. Its font size to vively adjusts responsively. Font weight bold emphasizes the temperature value. And margin 10 pixel 0 creates vertical spacing. The color muted blue tone ensures consistency with the city name. For the weather status, the text color is set to medium gray, and the font size to VW to ensures responsive scaling. Finally, the weather icon class styles the weather icons. The properties width 150 pixel and height 150 pixel define consistent dimensions, while margin bottom 10 pixel adds spacing below the icon. The media query at media max width 600 pixel adjusts the layout for smaller screens. The body receives increased padding with padding 20 pixel VH. The H1 font size is reduced to font size 35 pixel for better proportion. In the weather container, the grid template columns 1FR ensures a single column layout, and gap 15 pixel reduces spacing between cards. The weather card padding is decreased to padding 15 pixel for a more compact look. The city name and temperature font sizes are adjusted to font size 40 pixel and font size 38 pixel, respectively, while the weather icon dimensions are reduced to width 90 pixel and height 90 pixel. This comprehensive styling ensures a responsive, visually appealing design across all screen sizes. The JavaScript code begins by defining an object named city coordinates, which stores the latitude and longitude of 3 cities: London, New York, and Tokyo. This object allows the program to quickly access the geographical coordinates needed for weather API requests. Each city is stored as a key, and its respective latitude and longitude are provided as values in an object format. Next, we define a helper function called getWeatherIcon. This function takes a code parameter, which represents the weather condition code provided by the Weather API inside the function. A predefined object maps weather codes to corresponding image paths for weather icons, such as clearday.png or lightrain.png. If a code doesn't match any predefined key, a default icon, default.png, is returned. This function ensures that the correct visual representation of the weather is displayed on the card. The script then introduces the fetchWeather function, which is responsible for fetching weather data for a specific city and updating its corresponding card. This function takes 2 parameters, the name of the city and the card element to update. Using the city name, the latitude and longitude are extracted from the city coordinates object. A URL is constructed using these coordinates to make a request to the OpenMeteo API. The API endpoint retrieves current weather details, including temperature and a weather code. The function uses the fetch method to send the request to the API. Once the response is received and converted to JSON format, the script extracts the temperature and weather code from the current weather property of the API response. The temperature is rounded and displayed in the card's temperature element, while the weather code is passed to a second helper function called getWeatherDescription. If there's an error during the API request, such as network issues or invalid data, the catch block handles the situation by updating the weather status element to display an error message. Error fetching data. The getWeatherDescription function maps weather codes to human-readable descriptions, such as sunny, cloudy, or thunderstorm. Like the getWeatherIcon function, it uses an object to define the mappings. The corresponding description is then updated in the weather status element of the card. Simultaneously, the weather icon source in the card is updated using the getWeatherIcon function and the provided weather code. Finally, the script selects all elements with the class weather card using document.querySelector all and iterates through each card with a for each loop. For each card, it retrieves the data city attribute to determine the associated city name and then calls the fetchWeather function, passing the city name and the card element. This dynamic and scalable approach ensures that each card fetches and displays the relevant weather information based on its assigned city. Once the code is complete, preview the project in your browser. You'll see beautifully styled weather cards for London, New York, and Tokyo, displaying live temperature, weather conditions, and a matching icon. The layout remains perfectly responsive across devices, and the hover effect adds a polished touch. That's it for today's project. We hope you enjoyed building the responsive weather card application. Don't forget to like this video, subscribe to Code Instinct for more hands-on tutorials, and hit the notification bell to stay updated. Join us on Patreon for exclusive access to source codes and additional perks. Thank you for watching, and we'll see you in the next tutorial.